At the end of this lecture, you're going to understand how we can implement subnetting. Now, I'm actually going to cover subnetting over a few lectures in this section. Subnetting is a really important topic, not just for passing the CCNA exam, but for networking in general. It's really one of the core knowledge areas that you need to understand if you're going to work in networking. So if you need it, take a quick break before you watch this lecture, then get yourself a cup of coffee and come back, and we're going to dive deep into networking. Okay, to understand this lecture, you need to think about it from the context of the originally intended IPv4 design, just like we did in the previous few lectures there, where all hosts which can communicate on the internet have a public IP address. Now, if you're already working in a company where you've already got exposure to working on the network, the chances are that your company is going to be using private IP addresses. Now, as we go through these lectures, do not think about it from that point of view. Okay, we're going to get into private IP addresses later, and I'll also explain how modern day networks work. But before we get there, you need to understand how IPv4 worked in the first place. It's a natural progression. Understand this first, and then you'll be able to understand why we use private addresses on our networks and how they work as well. Okay, so just bear with me and think about it from the point of view of how the internet worked like 10 or 15 years ago, before we were running out of addresses and before everybody was using private addresses. Oh, while I say that, by the way, the majority of companies are using private addresses, but there are a few out there that are using public addresses everywhere. That is pretty rare though. Okay, so for our example, let's say that we're a network designer for a small business with 4 departments that are spread over 2 offices, and we want to manage our own public address space. So what we could do is we could buy 4 separate Class C networks for that. But the problem is that public IP addresses cost money. So rather than doing that, rather than buying separate networks from the internet authorities, we could purchase a single range and subnet it into smaller portions. Like, let's say we've only got a handful of hosts in each of those departments. Rather than buying 256 addresses for each, we can buy a single Class C range, and then we can divide that network up into smaller networks and assign it to the different parts of our networks. So in the example, let's say we've got that Class C range, and it is 200.15.10.0/24, the default Class C subnet masks. So to do our subnetting, to divide that network into smaller subnets, we need to borrow some host bits and add them to the network portion of the address. So we're going to move the line that separates the network portion of the address and the host portion further over to the right. So we're going to take some of our host addresses away and give them to the network portion of the address. When we do subnetting, the line always moves to the right. And the further to the right we go, the more subnets that we're going to have, but the less the amount of hosts that we'll have on each subnet. To calculate the number of available subnets that we're going to get by moving the line to the right, we use a formula of 2 to the power of subnet bits. Now, the first time I saw this, I thought, oh, I don't know how to do to the power of, never really covered that in school much. Don't worry, it's super simple, as you'll see as we go through these next few lectures. So if a Class C network uses a /28 subnet mask, then we've borrowed 4 bits from the default of 24. Okay, normal Class C mask is a /24. If we change that to a /28, the difference between 24 and 28 is 4. The way we calculate how many subnets we're going to get by doing that is it's 2 times 2 to the power of the amount of subnet bits that we borrowed. So we borrowed 4 bits for the network portion from the host portion. To see how many networks we're going to get, it's 2 to the power of 4. To calculate this, it's dead easy. You can do it on your fingers. You start off with 2 and you just double. So I go 2, 4, 8, 16. I'm going to now have 16 available subnets. Another example, if a class B network uses the same /28 subnet mask, well, the default for a class B is /16. So if we subnet that to a /28, we've borrowed 12 bits. To see how many subnets we're going to get, it is going to be 2 to the power of 12. So let's do this one. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096 subnets. For that one, you might have noticed it's easy if you remember that 2 to the power of 10 is 1024. Here we just keep doubling each time. And remember that hosts on different subnets need to go via a router if they want to communicate with each other. That's the whole point of having our IP addressing and of doing subnetting. It's to divide our network up into different logical parts of the network, and it's the routers that are the device that know how to get everywhere and that can direct the traffic. Okay, so that was how to calculate the number of subnets we're going to get. It's 2 to the power of how many bits that we borrowed. To calculate the number of hosts, it's 2 to the power of how many host bits there are minus 2. We need to subtract 2 because we've got the network address and the broadcast address that cannot be assigned to hosts. That's the 2 that we take away. So if a class C network uses a /28 subnet mask, then we've got 4 bits left for hosts. There's 32 bits in the address. If we're using 28 for the network portion, that leaves 4 for the host portion. 2 to the power of 4 is 2, 4, 8, 16, minus 2 for the network address and the broadcast address. That means that we would have 14 available addresses for our hosts. If we've got a class B network and it's using a /28, again, we've got 4 bits left for our hosts. So 2, 4, 8, 16 minus 2 is 14. It's exactly the same. So notice that the amount of hosts we're going to get is going to be dependent on the subnet size, and it's going to be the subnet mask size. It's going to be the same whether it's class A, class B, or class C. But the amount of subnets we'll get, if I go back a slide, it's going to be different for class A, B, or C because they've got different default subnet mask sizes. For example, if we use a /28 with a class B, then we're going to have 4096 available subnets. If we use a /28 with a class C, we're going to have 16 available subnets. There's a difference there. But for the hosts, it's always going to be the same. Okay, a quick note on IP Subnet Zero command. Just like we have to subtract 2 to get the number of valid hosts, back in the day, we used to also have to subtract 2 from the number of available networks. This is because in the original internet standards, it wasn't allowed to use network bits of all zeros or all ones, just like we can't use host bits of all zeros or all ones. So that took away 2 of our available subnets. However, there wasn't really any practical need for that, and it wasted address space. There is a practical need with the host bits because we've got that network address and the broadcast address that are actually used, but as far as the number of subnets go, we were taking away 2, not really for any good reason. So on Cisco routers now, for quite a long time, there's a default command of IP Subnet Zero, which disables that behavior. The command is enabled by default, so those 2 extra network addresses are available in Cisco networks. It's important that I tell you this because you might look up something on the internet, you might look up a subnet calculator there, and it will tell you that there are 14 networks available on a class C with a /28, for example, when I'm telling you that there's 16. Okay, with Cisco networks and for the CCNA exam, do not take 2 away from the number of available subnets. Okay, and I want to tell you that just so you don't get confused if you're looking up anything on the internet. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.